Hey, Integrated Math Superstars. We're here chatting about the quiz, practice quiz for 2-3 and 2-4. Of course, I'll be showing my work, and I expect the same of you. I won't even be using my phone or the internet or other resources. I don't even need notes, but on quizzes, you'll be able to use notes. So please make sure that you bring your textbook when you're filling out the quiz on quiz day, whenever that may be. All right, what's going on? I can guarantee the problem you'll see on your actual quiz is very similar to this. In this case, Jamie's truck has 28 gallons of gas. The truck uses 25% of the gas per hour. Model the amount of gas filling or remaining with a table, graph, and equation. All representations that we've used in the past. Okay, first one, fill up the table with variables and at least 4 points. So what do you think is being measured here? What are the two variables? What's changing? Hopefully you're saying that the gallons of gas is changing in comparison to the hour. So what I'm going to do here is kind of do the same thing. So I know that the hours are going to change, and I know that the amount of gas is going to diminish because that's how cars work, unless it's an electric car, and I don't want to get into that because Jamie doesn't have that. So what I'm going to do here is measure the hour. Over here, I'm going to measure the amount of gas left in gallons. All right, so at the very beginning, Jamie only has 28, so that's at hour 0. I'm then taking this further to hour 1. And so how's this going to change? How can we articulate this? Let's see. Well, I know that the truck uses 25% of the gas every hour. So maybe a visual will help. So 25% of the hour we lose. This is gone. And this happens every hour, okay? So if we're losing, so we're losing 25%. So how much are we retaining? Means that we're retaining 75% of the gas. And I'll put pH for per hour. And then we're retaining the 75% of the gas per hour. All right. So really, when I look at this, I think that I'm taking and I'm going to put this in words now. I'm taking the previous, multiplying again, because we're taking percentages, multiplying that with 0.75, and that should get me the current. And if you want to write that you're starting at 28, that'll help you eventually build in the recursive. All right, so as I go into this, I'm taking 28, and I'm multiplying it with 0.75, which just gets me 21. All right, does that sound good? So for hour 2 and 3 and 4, we would keep that momentum going. It's going to keep on going, trust me. So if we take 21, and I'll actually share everything now. So let me share my calculator. So I'm taking 21, multiplying it with 0.75. So that gets me 15.75. So let me report that back. So 15.75. And I'm going to just keep that momentum going. Multiply it with 0.75, which gets me to 11.81. All right. So 11.81, simple enough. 11.81. This actually is saying round to the nearest 10th. All right, I'll do that too. That's fine. So 11.75, this would be 11.8. And then if I keep that going, Multiply it one more time, 0.75, staying alive. This should be 8.9. All right, so 8.9. So let me switch back to just sharing this. All right, so our table should look like this when it's all said and done. So let's graph this out. At hour 0, there's 28. So let's mark that around here. At hour 1, there's 21. Ballpark that for there. At hour 2, 15.75. Ballpark that for here. At hour 3, 11.8. Right around there. Hour 4, 8.9. So around here. All right, so that was 2. Graph the points using the variables sketched in the table, done. Write in the recursive, we can do just that. Our starting point was f of 0. We're saying that that was equal to 28, f of n equals f of n minus 1 times 0.75. Explicit, we can build that off of what we just saw. So again, we started with 28, multiplying with 0.75. That happened n times. Done. The gas will never be completely gone because we keep multiplying with a fraction of the previous term. Domain, if it was real numbers, it would include fractions. If it were natural numbers, it would include 1 and then on. But we actually want whole numbers because this is including 0. So let me write that in. Reason we're using whole numbers. Let me just put it here. And this is obviously exponential. Why? It's creating an arch. That's good enough. You have house of horrors contaminated. This is doubling based off of the starting point of 5, so exponential. Same thing here. You can get, well, let's see. Assume that the relationship between hours and square feet of mole is continuous. So I would actually say that this is all positive real numbers. So this includes 0, includes all the positive numbers. That's fine. It includes fractions. Again, it's continuous. So that means that it doesn't skip a beat. Again, this was starting with 5. It multiplies with 2 x times. So A is the best. This is, well, starting with 30, then jumps to 60, then to 90. Hopefully we can see that from here to here, this adds 30. Here to here, this adds 30. Here to here, it adds 30. Whereas over here, it just adds 1. So that's a big deal. So it's definitely linear. The domain, it starts with 1 and moves forward. We don't want whole numbers because we're trying to measure how many workers we have here. We want, let's see, positive real numbers make sense because we're representing people. As far as the starting point, that might be a good place to start. If we were to keep going back to the 0 term, so I'll actually sketch that out here. This was 0, 1, 2, 30, 60. This would be 0. So our starting term is 0. So starting with 0, we add 30 x times. So that 1 right here makes the most sense. D. This keeps going, same kind of thing here, rate of change. This keeps adding 6 after every 2 years. So you would actually want to get the normal rate of change. So this is plus 6. This is also plus 6. But remember, you have a change in 2. So 6 over 2 gets you 3. So the rate of change in this case is positive 3. Patient receives 300 milligrams of medicine. Amount of medicine in the patient's blood decreases by 40% every hour. So starting with 30, it's decreasing by 60. So 100 minus 40 leaves us with 60. Sorry, should say decreases by 40, but leaves 60. So C makes the most sense. 300 is our starting term or initial value. Our constant change factor in this case is 60. Hope that helps. If you have any questions, reach out. Thanks.